Hi, it's Professor Logue again. Welcome to Chapter 10, Mobile and Embedded Device Security. There are 4 objectives that we're going to be talking about in this unit. They are: list and compare the different types of mobile devices. We live and breathe this stuff every day now, so this will be familiar to most everyone. The second objective is explain the risks associated with the mobile devices. We may be a little less familiar with that. List ways to secure a mobile device. The sim that you do this week on MindTap will help you do this in the example of an Android phone. And then lastly, describe the different types of embedded systems and Internet of Things, or IoT devices, and how to secure them. So let's take a look at the types of mobile devices. That's our first objective. When we talk about mobile devices, we have to consider what are the core features that they all share, and then what are additional features that might separate one particular mobile device from the next in the marketplace. So some of the core features that are representative of mobile devices is that they have the so-called small form factor. So it fits in the palm of your hand, for example, in the case of a smartphone or an Apple Nano, even smaller. That's a very small form factor. Additional features over here in this column, we have global positioning system, right? That would be add-ons. But let's look at the core features first in this column. They would have a mobile operating system, so much scaled down version of what you would see in a desktop. Wireless data network interface for accessing the internet, such as Wi-Fi or cellular telephony. So Wi-Fi now seems to be ubiquitous, meaning ever-present in all the devices that we have. Even refrigerators now have, that's a large form factor, but even refrigerators have Wi-Fi capability these days. And applications, the short name for that is apps, can be acquired through different means on these mobile devices. It might be an app store in the case of Apple, or it could be Google Play for Android devices. They also are noted for their non-removable data storage, as well as data synchronization capabilities with computers in the cloud. That makes them very useful, that they're always being backed up, so to speak, or synchronized with a fixed mainframe computer or some other cloud source somewhere. And in addition to the global positioning system for additional features, you'll often find these other capabilities: a microphone or camera. They're getting better and better all the time. Wireless cellular connections for voice communications. Something that we all know, Bluetooth. This enables what are called PANs, or personal area networks, and also near field communication that we talked about last week, like for example with Apple Pay. Also, they could be configured with removable storage and support for using the device itself as removable storage for another computing device. So we'll be looking at an aspect of that in this unit as well, this so-called chaining or tethering. Let's look at tablets. We have 2 slides on tablets. Tablets are a little bit larger form factor than, say, a smartphone. These are portable computing devices, larger than smartphones but smaller than notebooks. So the Apple iPad, of course, is what comes to mind here, but there are other tablet computers out there besides Apple's product. They're often classified by their screen size. They generally lack a built-in keyboard. They rely on a touch screen, but they can have an on-screen keyboard that is touch sensitive. They primarily are used as a display device. For example, it's probably not the best device that you would pick to do word processing. Most popular operating systems for them would be the Apple iOS, similar to what's running on your iPhone. A Google Android operating system in Windows also has an operating system scaled down for tablets. So this is an example of what one looks like. Again, we're all familiar with this. I'm going to include a video talking about actually demonstrating how ubiquitous tablets have come, especially for millennials and Gen Z. So taking a look at smartphones, this is a device that features a phone but includes an operating system. So in effect that makes it a computer. It's running apps, it accesses the internet. It seems as time goes on, smartphones just become more and more capable. A feature phone, which is a specific type of smartphone, is a traditional cellular phone with limited features. So not generally considered a smartphone, but it is rather referred to as a feature phone because it doesn't have all of the capabilities, but it's focusing on specific capabilities that you would otherwise find in a smartphone, such as a camera, an MP3 music player, and the ability to send text messages. But there might not be email, there might not be web surfing. Smartphones are considered handheld personal computers because they're running programs, they're running applications. That takes us to wearable technology. I think we're all familiar with fitness trackers and smartwatches, the Apple Watch, for example. They're wearable, so they can be worn by the user instead of carried. Fitbit is an example of a fitness tracker. Garmin also has these products. They monitor health and exercise by the user. And they can also be tethered to smartphones so that you can get a certain amount of capability even on this wearable device. For example, notification when a text comes in. This is what a Fitbit looks like. This is an example. It's called a fitness tracker in general. Then that takes us to portable computers. These have similar hardware and run the same operating systems and software that you would find on a full-blown, full-scale desktop computer. But they're portable. That means you can carry them from place to place. One of the earliest portable computers, I bought one myself back in the mid-80s. It was produced by Apple. It was called the Apple IIc. I still have it, by the way. And it was portable in the sense that it had a handle and you could carry it around, and it also had a separable LCD display that could be used. Nowadays, of course, portable computers are far more capable than they were back then. That was an old 8-bit machine. Now, of course, we have 64-bit machines and much more capable microprocessors. The primary difference between a portable computer and the smaller self-contained devices is, again, the mobility. They can transport them from one place to another, and they can operate on battery power. So that's a blessing and a curse, right? Because it's easy for functionality, but as we've seen time and time again in this course, once you improve the convenience, the capabilities, the functionality, there's some cost in terms of security. And in this case, that's going to be the fact that it's much more pilferable, can be stolen. You can leave it somewhere by accident. Laptop is a specific kind of portable computer. It's regarded as the earliest portable computer, and it has multiple hardware ports and can accommodate limited upgrades. So as opposed to a desktop, which has available slots for adding new cards, a network card, for example. So notebook computers are even smaller. They're a smaller version of a laptop. They weigh less than laptops, and you can fit them in a briefcase. And they're designed only for basic, frequently used features. You can think of like a Chromebook as an example, or even sub-notebook computers. These are smaller than the standard notebook. This, again, Chromebook comes to mind. They have a Chromebook would actually fall in this category. Uses low-power processors and solid-state drives. They have both a touchscreen and a physical keyboard. So this is an example of a two-in-one computer with slate design. So Microsoft Surface, I think, is what we're looking at right here, a specific type of portable computer that is convenient to use and highly portable. Then there's the so-called web-based computer. That's, for example, I mentioned Google Chrome. You would consider that a web-based computer because it has a very stripped down or limited version of an OS on it. In this case, Linux also produces web-based computers, and it would have the Linux OS and a web browser. It has an integrated media player, but the thing is, it is more or less what we call a dumb terminal. It doesn't have much processing capability. It's only designed to be used while connecting to the internet. The processing power is in the cloud, in the internet. This web-based computer is merely a conduit to access that information. There are no traditional applications, therefore, that you can install on it. So you'd be using Office 365, a web-based web-based Office suite of applications rather than Microsoft's Office stored on that computer. No user files are stored locally, and it accesses web apps and saves user files on the internet. So in this case, it's the information isn't stored on the computer, and in a sense then a web-based computer would be much easier to secure. Mobile device connectivity methods. How do we get to the internet using a mobile device? Well, by and large these days it's Wi-Fi. Wireless fidelity, as you recall. Many devices support other means. There's also cellular, satellite, infrared, something called ANT. This is a proprietary wireless network technology used primarily by sensors for communicating data. So you might not see this too often, but realize it's out there. This could be, if say you live in a community that's near the ocean, and you're concerned about tidal waves. Well, there are around many major cities out in some miles out in the ocean buoys that are actually using this proprietary protocol to transmit wave action heights and all this type of data to hydrographic research stations to predict when we might be subject to tidal waves. So that's one example. USB connections as well. I think we're all familiar with the universal serial board that can be used to connect most devices to our computers. So how do we deploy these? Well, there are several different models that are used within an enterprise to do that. You see them listed by name in the first column. There's also familiar acronyms for each. So BYOD, bring your own device. COPE, corporate owned, personally enabled. Choose your own device, that's CYOD. And VDI, which is virtual desktop infrastructure. And then lastly, we have corporate owned. So these are displayed here on a spectrum, and the variable that's changing as we move from one to the next is how much control does the user have. So at the top, the user has the most control. At the bottom, the user has the least control, the user being the employee at the enterprise. So let's look at each one of these. For BYOD, under description, it says that the employee, they basically bring their own mobile phone in and use it for business purposes. And in that situation, the employee has full responsibility for choosing and supporting the device. And the business or the enterprise, smaller companies like this because they save money. They don't have to buy cell phones for everybody in their, or smartphones for everybody in their organization. Obviously, this is potentially problematic because they cannot guarantee, the business has less control over the security posture of these devices if they don't even own them, as opposed to corporate owned, where the enterprise is responsible for everything on that device. So in that scenario, the other end of the spectrum, the device is purchased and owned by the enterprise, and the employee can only use it for business purposes, company related purposes, and they have to turn it back in when their employment terminates. In between these two extremes, though, you can see these hybrid models. The corporate-owned, personally enabled, in this scenario, the employees get to choose. There's a laundry list of approved devices that the company puts out there, and employees get to pick which model they want. So then they're supplied with the device that's been chosen and paid for by the company, but the company decides the level of choice and freedom. So they're putting together the list, and of course they're going to have already validated all of the security configurations for each one of those devices and used mobile device management, which we'll talk about in the next video, to make sure that the applications that are on those devices are not security risks. In the middle of the spectrum, we have choose your own device. This is where employees choose from that limited selection of approved devices, but now the employee pays the upfront cost of the device while the business owns the contract. So it's again a list of a suite of choices the company's approved for security, reliability, and durability, and the company kicks in a stipend to pay the fees for it. And then the other one listed here, the VDI, this is a virtual desktop infrastructure. What this is, in the description you can see what's happening is we're storing sensitive applications and data on a remote server that is accessed through the smartphone. So that way we could have better control of the proprietary data that the company might own. And then on the device, all it is an interface to get to that over the internet. So the employee can customize the display, but that's it. They can just customize that display as if the data were residing on their device, but because it's virtual, the enterprise can protect it centrally and manage the apps and data instead of having to do it on each end device. So let's talk about the benefits. I alluded to a few of them in the last slide. The benefits of BYOD, COPE, and CYOD. Management flexibility, less oversight, cost savings. A lot of organizations will jump on that to justify their choice of BYOD. Increased employee performance because the employees now have a device they're comfortable with. They had some say in which one was picked, and some people like certain apps, certain OSs more than other apps and OSs that other people might like. Simplified IT infrastructure, and the user benefits here: choice of device, choice of carrier, and convenience. So that's a description of the different devices that are out there and the capabilities and the different deployment models. In the next video, we'll start talking about the mobile device risks.